Hello, my lovely viewers. Welcome again to Maths Buddies and I. As you all know, I remain your presenter, Jefferson, and today we shall be looking at the topic known as joint variation. Now, so far so good, we have been able to give two videos on variation, which the first talk about direct variation and the other talk about the indirect or inverse variation. And today we shall be looking at the number 3 type of variation, which is called the joint variation. Now, what comes to your mind when you hear joint variation? From the word joint, it means where two or things come together, where they meet, the meeting point, the point of intersection. Now, when you say joint variation talks about two or more variables. Two or more variables that could be directly or inversely joint or connected to each other. Now, it means joint variation can take the following format. One, it could be something like this, N varies directly as N and P. Or it can be like something like this, M varies directly as N and inversely as P. Now, no matter which way it comes, just know this is a joint variation. Now, how do you solve problems on joint variation? The same way we have been solving problems with inverse and direct. The first thing we are expected to do is to find our constant of proportionality, and then we get the relationship connecting the variables given. Now, I'm also going to be introducing to you special cases under joint variation, which talks about constant times constant is constant, and not constant times constant as k raised to the power of 2, which we know as laws of indices. So we're going to be seeing something different here under joint variation. So before we waste our time, let us begin the class. Now, we are going to be giving 3 examples today. Just 3 examples to explain all what I have said. Now, example number 1. Okay, example 1 says, if P varies directly as Q and inversely as R, comma, when P equals to 6, Q equals to 12, R equals to 3. First off, find, comma, Roman figure 1, the relationship Roman figure 2, the value of P when Q equal to 1, comma, R equal to 3. Okay, now let us get this question done. Now, without wasting time, solution. We will notice that, okay, the format of this question is like the second format that we gave. Now, when we want to solve a problem like this, let us bring this question out. P varies directly as Q and inversely as R. Now, what's the first thing we're expected to do? To introduce our constant of proportionality, which is our K. Now, here it comes. P is equal to KQ over R. Now, once you introduce your constant, what's the next step you take? You get the value for the constant. And how do you get the value for the constant? By using the first 3 values that was given. Now, P was 6, Q 12, R 3. Now, substituting these values into this equation, we have this. P becomes 6 is equal to K bracket Q. Now is 12 all over R now is 3. Now what do? Cross multiplying. Base here over 1 and cross multiply. K12 times 1 will also give us K12. 6 times 3 will give us 18. Now, if we are looking for the value of K, we have to divide both sides by 12. Now, dividing both sides by 12, when 12 cancel out, so what do we have left? K. Now class, what can cancel 18 and 12? Now the highest number that can cancel 18 and 12 is 6. Now 6 into 18 is 3. 6 into 12 is 2. So it means the value of our constant is 3 over 2. Now remember, we were not told to look for the value of our constant, but you must look for the value of constant. Now that we've gotten our value of constant to be 3 over 2, what are we looking for next? The relationship, which is Roman figure 1. Now relationship is, now the relationship connecting P, Q and arrow, how do you get it? The very position you introduce your constant. So what does that mean? Anywhere I see K, what will I give there now? 3 over 2. So automatically the answer becomes P is equal to K now is 3 over 2. What do we have on top? Q. And what do we have down? Arrow. So the answer becomes P equal to 3Q over 2 arrow, which is the relationship. Now that we have gotten our relationship, Roman figure 2 says we should find the value of P, meaning P is unknown. When Q is 1, Q equal to 1, and our arrow is still 3. Arrow equal to 3. Now, how do we get the value of P? By using the relationship. It's as simple as that. So automatically here becomes P is equal to 3 bracket, this is Q. Now Q is 1 over 2 bracket, this is arrow. Arrow is 3. Now without wasting time, here becomes P is equal to 3 times 1 gives us 3, 2 times 3 gives us 6. Now we all know something that cancel 3 and 6, and that is 3. So the final answer becomes 3 cancel 3 will give us 1, and 3 cancel 6 will give us 2. So the value of P when Q is 1 and arrow is 3, using this relationship, will give us what? 1 over 2. Okay, now that is example number 1. What if we have this type of example? Example number 2 now. Let's be fast about this, okay? Example number 2. Now, example number 2 says, if, let's say, n varies directly as n and p, comma, when n equal to 20, comma, n equal to 2, then p equal to 5. Full stop. Find Roman figure 1, the value of constant. Roman figure 2, the value of n when n equal to 2. Okay, let's say when n equal to 4 and p equal to 1 over 2. Let's use a fractional number. Okay, now taking a look at this question, what do we do? Now without wasting time, we have this. Bringing out this in mathematical form, solution, n varies directly as n and p, they are joint. So here becomes varies directly as n, p. Now introducing your constants, here becomes n is equal to k n p. Now, the next is for us to get the value of our constants. And how do we get the value of our constant? By using the values of these 3 variables. Now, in the question given, n was 20, n 2, p 5. Now, substituting these values, we have this. M now is 20, is equal to K bracket, N is 2, and P is 5. Okay, now let us open the brackets. Here becomes 20 is equal to K times 2 gives us 2K, and 2K times 5 gives us 10K. Now, when we are looking for the value of K, we divide both sides by 10. Over 10, over 10. Now, when 10 cancel out 10, what do we have left? K is equal to 20 divided by 10, will give us 2. Now, remember Roman figure 1. Roman figure 1 said, what is the value of the constant? Now, class, what is the value of my constant? 2. Now, Roman figure 2 says, we should, okay, now, before we can find Roman figure 2, what did I say you do next after you get your constant? You find your relationship. Now, looking for our relationship now. Our relationship is, now where do you normally get a relationship? That very spot that you introduce your constant of proportionality. So automatically, here becomes M is equal to K now. The value of K now is 2. Here becomes 2, and what do we have here? NP. That becomes our relationship. Now, if our relationship is M equal to 2NP, what are we now going to do now? We're going to do for the what? Our Roman figure 2. Now, solving Roman figure 2, they said we should find the value of M, meaning M is unknown. Now, when N is 4 and P is 1/2. Okay, now, what do we do now to get the value of M? By substituting these values into our what? Our relationship. Now, without wasting time, we have this. Using the relationship, anywhere I see M, I will give M because I don't know the value of M. Now, here becomes M is equal to 2 bracket, N now is 4. Another bracket, now this is P. P is 1/2. 1/2. Now, opening the bracket, we have this. M is equal to 2 times 4 gives us 8. 8 times 1 gives us 8. So we have 8/2. Now, class, 8/2 will give us just one answer, which is what? 4. So it means if we find the value of M, given these values and this what? Relationship, the value of M will give us what? 4. Example number 2. Now, remember I said that the last part of the example for today is going to be special case on joint variation. Now, how do you notice a special question under variation? The question differs. There's the way the question looks like. And we're going to solve just one example under that, and we are good to go for today. Example number 3. Example number 3. Okay, now example number 3 says, if P varies directly as Q and Q varies inversely as R. Full stop. Now watch. Find, comma, Roman figure 1, the relationship between P and R. That's 1. Roman figure 2. The value of constants if, okay, P equal to 20, arrow equal to 5. Okay, now let us take this question and then see what we are going to do about it. Now, but I want to bring something to your notice. I want you to notice something. Take a look at this question. Initially, the question says, if P varies directly as Q, and Q varies inversely as R. Now, from the beginning of the question, 3 variables were mentioned. P, Q, and R. Now, notice something. Now, look what it said we should find. Find the relationship between P and R. Something has happened. They have narrowed these 3 variables to become 2, P and R. So, what are they telling us to do? Eliminate Q from the mass. Make sure there's no Q. Because if they want to be Q, they will say, find the relationship between P, Q, and R. Now, how do we eliminate Q? Simple. This is what we'll do. Let's bring them out one after the other. Now, the first part says, solution. P varies directly as Q. Now, let's introduce our constant. It means P is equal to KQ. Call it equation number 1. Now next, Q varies inversely. Inversely means 1 over, as what's now? R. Now let's introduce our constant as well. Here becomes Q is equal to K over R. Call it what? Equation 2. Now mind you, what are we eliminating? Q. Then you will now check between equation 1 and equation 2, which one has Q as the subject of the formula? It is simple and clear. It is equation 2. Because in equation 1, P is the subject of the formula. Now, because in equation 2, we have the subject of the formula as Q, what do we do? In equation 1, anywhere I see Q, I will put K over R, because that is Q in equation 2. So rewriting equation 1, I got this. Here becomes P is equal to, this is K, bracket, Q now is what? K over R. You close your bracket. Now remember from the beginning of the math, I told you, under special joint or under special joint variation, constant times constant is constant. Constant divided by constant is constant. So what does that mean automatically? It means that opening this bracket, P is equal to constant times constant is constant and not constant raised to power 2. Now, without wasting time, over R. Now, class, you will notice that in this new relationship, there is no more what? Q. We have finally eliminated Q from the mass. So, Roman figure 1 says, what is the relationship between P and R? Now, the relationship between P and R is this. P equal to K over R. But how is the question said? How does P vary with R? It means P vary inversely as R. Because R is down, inverse. Okay, now, this is Roman figure 1, which is the relationship. Now, Roman figure 2 now said, we should now find the value of the constant. Now, for us to find the value of the constant, the values of P and R must be given. And yes, it was given. P was 20 and R 5. So, Roman figure 2. So find K, meaning K is unknown. But P is what? 20. And arrow is 5. Don't mind my marker. Okay, now, substituting these values into the relationship, we have this. P now is 20 is equal to K over 5. What do we do? Base 20 over 1 and cross multiply. K times 1 gives us K, and 20 times 5 gives us 100. So it means the value of our constant of proportionality, when the value of P is 20 and the value of R is 5, is what? 100. I believe you have learned something then, something new today from joint variation. And I believe with these 3 examples, you can be able to solve problems that are related to joint variation. Till we meet again in our next class, always remember to subscribe, to comment, and to share, so that people that are needing this, we get to see it. Till we meet again, thank you very much.